Hi folks, Captain Carl Burnside here, Thumbs Up Charter Services, another episode of Thumbs Up Charter Services Behind the Scenes. As we alluded to in one of our previous videos there, as we finished painting the Ambrose, you can see my breath in here. It's getting a little cold in Michigan. We're going to start wiring the boat. And tonight we're going to start with the 120 volt side, which is the dockside power or shore power that we need to charge our batteries, and also we have an outlet in the boat here and there, just like your house, so we can clean and vacuum the boat or clean the boat with equipment between charters. So that's the circuitry we're going to work on first, and that circuit on any given dock is usually going to be 30 amps. I don't need somebody to come back to me, well, I've got 50 because I've got a yacht that should be on the lifestyles of the rich and famous. That's fantastic. You need another video for that. But for typical boaters, you're probably going to run into a 30 amp circuit. And we're going to show you the weatherhead that we use, that we put in the boat, that makes that shore connection, and also how we're going to wire it. So stay tuned. Here we go. All right, bear with me here. We got a little rain in Michigan, but we're going to have snow tomorrow, so everything will be all right. All right, we're going to start with the weatherhead unit that actually goes like in the gunnel of the boat or wherever you choose to mount it. We put ours in the gunnels. And this is made by Marinco. It's a 30 amp, 125 volt connection. It has a weatherhead on it. When you open it, it exposes the three lugs on the inside of here, the power, the neutral, and the ground, that go to your shore power. There's a cable that'll come in here that you connect to the shoreline power. You push it down, you twist it about quarter turn, and it locks in place. Right there you can see there's a lug that does that. When you're not using it, the lid goes down onto the unit, and this is a little bit newer style one, there we go, and then it locks into place to keep moisture out of it. On the back side of it, there's three connections. You have a ground, which is colored green, the power supply, the 120 volts, which has got a black ring around it. You may not be able to see that. And then the neutral, or the white wire, just doesn't have anything around it. You can also identify these by the screw colors: green for ground, black for power, and like a stainless looking bright color for neutral. So what we're going to do is we're bringing 30 amp service to the boat. In order to do that, on the other side of this, inside the boat, we're going to have a distribution box with a set of fuses in it, or a circuit breaker, just like your house. And pretty much so far, this part of the wiring on a boat follows like the National Electric Code, because you got to be safe and, you know, not shock people or yourself. So a 30 amp service from the weatherhead to the circuit breaker box, or to the fuse box, is going to require a 10 gauge wire. And as you can see, we have three conductor. We have the power, the ground, and the neutral. The wire is rated at 10 ABYC for its gauge. It's also identified as boat cable. It can be used in wet places and made in the good old US of A. The difference between boat wiring and your house wiring is two things. Boats move a lot. They vibrate a lot. This is not solid core wire. It is stranded. The other way it varies, and you'll see here in a minute when I actually remove the insulation, the wires are, each strand is individually tinned. It's copper wire that's been tinned, and that's very important. That prevents any corrosion in the marine environment, or helps prevent it. Using standard copper wire in a very short amount of time, you will have corrosion. Now, with that said, some older boats, this one not excluded, unlike the main engine wiring harness and things, aren't using the tin-coated copper wire. They're just using copper wire. But they've protected that wiring through weatherproof connections and using stainless end pins and things in the umbilicals. And we'll show you that when we get to the engine wiring. But just know, if you're doing new wiring on your boat, you got to use marine wire, or you should, and it should be tin-coated strands to prevent corrosion. So what we're going to do is wire this up, and we need to skim back some of this outer sheath about 1.5 inches of it. You just use a box cutter, carefully cut the outer sheath, pull it back to expose your wiring, then come along in here and cut this off carefully. And be very careful doing this with a box cutter, because I've sent myself to the emergency room more than once. Not proud of it. It's not a badge of honor. It's just stuff happens, right? So now we're going to do is skim back about 3/8 of an inch, maybe a little bit more, maybe 7/16 of an inch of the insulation on the inner conductors. Two things when doing this: have a pair of tin snips, makes cutting the wire easily to length. Definitely have a pair of wire skinners, insulation skinners, makes life a lot easier. Just put it in there, pop it off, and as you can see, that wire, that copper wire, has been tinned. And we got to do all three here. Whoops. There we go. And we're going to want to twist them. Keep our wires from straying away. We don't want any little strands outside of what we're going to do here. And once we've got that done, there's jaws in here that are controlled by these screws at each terminal. We've got to open those up so we can get the wire in. Kind of like that, just until it gently stops. Open the jaws up completely. There we go. Now there is a protector that goes over this, so we're going to have to feed the wire through here into this cup, and then into each of the individual terminals here in the weatherhead. So we'll start by simply taking our cup. Cup has a strain relief in it too that will tighten on this wire once we're all set here. And you just bend the wire around, get it fed through. And this could be a little difficult because 10 gauge is a little stiff. Once we get to the fuse box or circuit breaker box inside the boat, what we call the distribution panel, we're only going to have a 15 amp fuse in this boat, or circuit breaker in this boat, because we're just powering like a vacuum cleaner, maybe a drill, whatever we need to fix the boat at the dock, and also charge our batteries because we have onboard battery chargers. So we will not be using 10 gauge, we'll be using 14 gauge wire, but it will be marine grade just like this. This is a smaller gauge going out to those outlets on the boat. So we got our cup here. We know the orientation of which way we want the cup to set when we put it into the boat. And what we're going to do is simply just pick a circuit. I try to line them up. So there's the power, there's the neutral, there's the ground. And what we're going to do is simply put, let's pull this back a little bit farther, one of the wires into the holes. Again, it's a little tricky to get this stuff to cooperate with you, but we're going to do the neutral first. So we will put that in here like that. Make sure we don't have any strands hanging out by itself, and then we will tighten the screw down to hold that in place at that terminal. And you want to get them decently tight, not over tight. It's good there. The next one we'll do, I think we'll pick the ground. And we'll do the same thing there. Simply bend it up and into the hole. Easier said than done. Again, checking for strands, making sure I don't have any strands out there. And we'll tighten that up. Boy, here comes the rain again. So you get the idea. I'm going to cut this off till the rain goes away here. I'll get this last one, then I'll show you how the cup goes on. Okay, as luck would have it, rain's down to a temperate level now. So we'll continue. But in that time, I got the power conductor in. Then we retightened and checked both of the ground and neutral to the weatherhead. Made sure they're in the proper terminals. Make sure there's no strands hanging out here that could short out or cause a problem. So the next thing we got to do, there's a screw hole down the middle of this that this cup screws into or tightens with. So we got to feed the wiring down through the cup. And like I said, easier said than done because it's 10 gauge. We got to keep that wiring clear of that post right here where the screw goes, which looks like it's going to do for us. We've oriented this wiring the way we want it in the boat, the direction we want it in the gunnel. And we put this down, and there's a locking feature here that we line up. There we go. Then we simply find our screw, put it in the top of the cap here, or the cup, the protection cup, and then we tighten it up. There it goes. Self-thread, self-starting screw, so you got to kind of help it out a little bit. There she is. She's tight and snug to the body of the weatherhead. Then the strain relief we tighten up by turning this screw, and that holds the wire in the cup so it can't move around in vibration or if it gets pulled on or whatever. And at that point, you want to kind of center that up in there if you can. At that point, our weatherhead is complete. The next step will be to put this in the gunnel of the boat. We do have pre-drilled holes in the gunnel. Show you that in a minute if the rain will calm down. Never thought I'd want to see snow. Snow is quiet on this tin building. But they were put in by the previous owner. There's one on the port and one on the starboard side. And we're actually going to put two of these in, and we'll explain why in a minute. One on the port, one on the starboard. We have that luxury because the guy already cut two holes for these. All the equipment was old, we removed it. But he did a real poor job of cutting the holes, and we're going to have to clean it up with a rotary file so the cup will fit in there correctly. It's really hacked up through the aluminum. And then we'll have to drill some new mounting holes here, 4 of them, for our weatherhead to be securely put in to the gunnel. You can see here, this is the hole we're going to use to put our weatherhead in. Somebody just, I don't know, chiseled through the boat to put this in. So what we're going to use is a rotary file with a 3/8 drill to clean this up. Alright, so we got the hole cleaned up. Should be big enough now. We're going to check it here in a minute. Not a robot or a laser guided robot or anything like that, but for the human eye it looks pretty good. You grab a weatherhead, and we're working on the starboard side of the boat. So when we put this weatherhead in, we're going to have to drill some new mounting holes, but there is a gasket goes between the weatherhead and the gunnel. Keep the water out. But we're just test fitting right now. So we got our 10-3 conductor cable here. Slide her on in like that. Looks great. So we'll square her up here. Pilot drill the 4 mounting holes. Then drill through to the correct size, and then We'll put the gasket, pull this out, of course, when we're doing this, and we'll reassemble with the gasket and the hardware and get her tightened up. We're back with you here. It's a couple days later after we're drilling up there and using the rotary file on the gunnel to get that weatherhead in. It's not raining, which is a good thing, so you should be able to hear me okay, except for the buzz of the heater in here because it snowed. So I'm just excited about that. But we do have shore power in. And you're probably saying, what? I thought you were going to show me this. Well, I'm going to show you some of the general detail. The problem is you have to follow ABYC rules, which is the American Boat and Yacht Council. They have rules set up about how to wire a boat depending on the configuration of the boat, what the hull is made out of, you know, etc. It depends if you have an aluminum boat or a carbon fiber boat or a fiberglass boat. So rather than show you the detail of what I did specifically, I'm going to refer you to a link at the end of the video here that if you're thinking about doing this project, you should really sit down and read this. It's a link directly to the ABYC rules on 120 volt service entrances into boats. And you can sit there and look at all the different designs and schematics and figure out what you need to do for your situation, because it'll probably be different than mine. So with that said, we're going to climb up here. Furnace turned off. We'll show you what we did, how we routed it, what equipment we used, some of the precautionary things you're going to have to look out for, and then we're going to show you how we're working or started to work on the 12 volt system. And we'll have a lot more detail on that. Pretty specific stuff about, you know, how we're wiring it, the bus lines we're putting in up to the dash, things of that nature. That's much more straightforward and much more generally accepted on most boats that you're going to run into, unless you own a yacht, like I said before. Otherwise, you can hire your own electrician. Here we go. Before we get into showing you some of the things we did here for our 120 volt shore power system, it's important that we talk for a quick moment about ignition protected devices and where they're used in a boat. Ignition protected devices are used anywhere where explosive fumes may be present. That would be like where we store fuel in either side of the boat gunnels here in our application, or in the engine doghouse area, which is behind me, or in the transom of the boat, where, you know, pumps and motors and fans would be running, and sources of spark ignition could set off an explosion if flammable vapors were present. So ignition protected devices would include things like your starter motor and alternator, if you have an inboard, bilge blower fans, electrical lights, switches, relays, circuit breakers, and ignition components like distributors. And the list kind of goes on, but it gives you a general idea. Anywhere that flammable vapors are present in a boat, ignition protected devices must be used. And that could influence where you're going to put in your shore power connections and your shore power equipment. So keep that in mind when you're designing a shore power system for your boat or planning to have one installed. In our situation, our shore power is out of those areas, so the ignition protected angle of the components is lessened, and the requirements are lessened under the ABYC rules. We'll start at the weatherhead, and here's the one on the starboard side that we put in, fully installed, screws in place, gasket, and secured to the gunnel. Walk you over here to the port side, and here's our other weatherhead that we have plugged into a 30 amp service cord. It's a shore cord like the one we use at the dock. In fact, it is the one we use at the dock. In it again, the weatherhead has been installed, secured, and sealed, and all that good stuff, and it's actually powering the boat right now. So the reason why we actually put two in this situation, we had the opportunity, first of all, to do it, and I mentioned I was going to explain this before. But right now, you know, boating is at a high fever pitch, I guess you would say, and it's getting more difficult for us to find dock space, and we may not always get the dock we want, which we prefer the port side. It's just a personal preference. But in the event, which will probably happen, that I don't get a port side docking, I've got provision for starboard side, and it makes it all that much easier. So how we did this was, this is the starboard side. Wiring comes in underneath the gunnel. So you can see there's the weatherhead right there. Loops up, comes through the gunnel of the boat. We have chafing protection here where it comes through the aluminum. We have chafing protection up here where it goes through the aluminum again into the hardtop. Routed this across this channel. Got some wiring here that we've got to clean up. Comes down again through the top of the hardtop with some chafing protection there. Does the same thing here. It's been put into conduit. See some of the blue conduit back there behind the circuit breaker box. Both these circuits come down into this box on the top. So everything from like halfway through this box, if you can imagine, up this way, out to the gunnels, each gunnel of the boat is covered by a 30 amp service that has 10 gauge wire to it. That's important because the dock connection and breaker on the dock is 30 amps, and that is what is protecting that. The lower half of the box, it goes through a circuit breaker here, 2 circuit breakers actually, one for each side, port and starboard. That comes down, and they're 15 amps. It goes down into this transfer switch here that we still got to seal up here, make it weather protected. And that transfer switch automatically picks and isolates one side of the boat and allows the other side of the boat to provide the power. So if I'm plugged into the port side, which I am now, the port side is live, the switch detects it, it locks out the starboard side so nobody can be electrocuted or hurt if they open up that weatherhead on the starboard side and stick their fingers on the terminals or whatever. So at this point, like I said, from halfway through this box down, it's 15 amps. We have 2 places, very simple circuit where this is going. It goes to that GFI plug right there. As you can see, I have my light plugged in. I also have my vacuum plugged in there. And then it loops up out of the bottom of this, up through the gunnel, down the port side gunnel. As you can see, there's some of it there behind this fuel tank I got sitting here. And at the back of the boat, it comes out to the transom. And it's going to be about halfway across the transom. I've got a temporary plug on it, so I can use it as an extension cord right now as we build the boat. That will be hardwired eventually into a weatherproof box that is ignition proof. And our battery charger will feed off of this. It'll be up here tucked in on the transom eventually here as we progress. But right now, it makes a great extension cord, and that's what we're using it for. As you can see, there's a pigtail coming off of here. That's a ground. And in our situation, per ABYC rules, that has to be bonded to the engine once it's in. So, like I'm saying, there's a whole lot of rules that you've got to read, depending on what kind of boat, what kind of outdrive, or maybe you have outboards and not an IO. There's a whole lot of rules that you've got to look at and plans you've got to review to decide exactly how to wire your 120 volts into your boat. So with that said, that's pretty much done. We got to do a few cleanup items here, tucking up wires and things. One thing I did want to mention is anywhere in any of the wiring in a boat, no wire nuts. As you can see, we've got crimp and shrink connectors here to keep moisture out. Positive crimp connections of the proper type for the wire size. And wire nuts have no business being in a boat. You see a lot of folks do this with lamp cord. I don't know how many boats I bought that actually had lamp cord coming off of the battery. Lamp cord going to various accessories with no fuses on them. Everything has to be fused. It has to be fused as close as possible to the source, power source. So, you know, you don't want any length of wire coming off a battery down halfway down here and put a fuse here, because that length from the fuse to the battery is not protected. If you get a short, especially an aluminum boat, you're going to have a fire, and guess what I got there? I got a fuel tank. So that would be a really interesting experience that I don't want to have. So those are the kinds of things you're going to want to keep in mind when you're trying to put shore power in your boat. Like I said, we'll provide you that link, and it's very helpful, easy to understand information. Just need to sit down and take a look at it. So the next thing we've been doing, we've been somewhat productive on here this week, is if you can see back here in the gunnel, we've got our circuit breakers, 4 of them that are 40 amps each, and our battery selector switch mounted along with our battery boxes. And we're going to bring in a bus line of 8 gauge to each of those circuit breakers. And those 8 gauge bus lines are going to come up along here, along this gunnel. And they're going to travel up in here. And they're going to come up to our helm, where we have some of our gauges and other things kind of just somewhat mounted here. But they're going to be powering these 2 panels. Every accessory on this boat that I'm putting in, GPS, chart plotters, VHF radio, accessory AM/FM radio, fans, wipers, lights, anything will be powered through these 2 switch boxes here. They each have their own individual 15 amp breaker tube. There are some situations here, down here, for some of our sensory control things, like our fume detector, water alarms, and fire suppression system, that require milliamp, and will have to be run on their own individual fuses off of one of these main bus lines. That gets them down to maybe anywhere between 2.5 to 2 amps to 7.5 amps, I think, is what the fuse sizes are required to run these. But for the majority of the boat, we're going to be running off the circuit breakers, which is great, which makes it easy. Push a button, reset something, and something happens. It really shouldn't. It's important to note that we will be using the original Maricruiser wiring for only one thing, what it was designed for. Running the gauges, like the tack and the fuel and the trim and all that. And the ignition system, because the switch is going to be right here. And that would be, the operation of the outdrive and engine, along with the trim for the outdrive. Beyond that, any other accessory, we run them off of multiple circuits. Like I said, 40 amps will be coming up here. Be 4 circuits of 40 amps coming in here. And each one of those 40 amp circuits or buses will control about half of each one of these panels individually. We will mix our chart plotters between at least 2 buses. So if a power bus goes down, we've at least got 1 chart plotter to get ourselves back. In other words, what I'm saying is we don't put all of our equipment on one bus line. It's just an added measure of safety. So as we progress with this, we will show you some of that going in. We've also got our throttle and shift cables in. They're brand new. We've also got our, you see it down there, our steering cable. It's coming up here. Those are running along here. They've got to be tied up in the back down here and properly supported, but there they are, running to the back of the boat, running around the corner, and then going down in the engine compartment. You guys will see all that going too. We've also staged our bilge pump on its mounting bracket with a float switch. These bilge pumps will be controlled by the dash on one of those switches I just showed you. They will also have their own separate power feed back to the batteries, so that switch will work in the event we're not here and we get a torrential rain and the boat starts to flood. That switch could trip the pump and blow the water out while we're not here. Well, I think that'll do it for today's episode of Thumbs Up Charter Services Behind the Scenes. Thanks for joining us today. Next episode, we're really going to start digging in deeper on this 12-volt system. And we'll start with the bus lines, the 40-amp bus lines I talked about, 4 of them, come off those circuit breakers and go up here to feed our helm. Power all of our equipment up there with it, like our radar and radio and depth finder, all kinds of good stuff. We're also going to talk about autopilots and in particular the Raymarine Evolution autopilot. And we have to exclusively use those on our boats. They're a great system. I get a lot of questions at docks about autopilots, people interested to put them in their boats. I think this is a good opportunity to show you some of the components, what's generally included in those kits, and the different options to power that and steer your boat. We'll get into that a little bit, give you a nice skeleton frame about how those things work and how you might have to adapt them to your boat as well. So I think I got some, I've got some copper wire that came out of this boat, some old time stuff. I'm going to try to find an good example, I'm betting I can, of corrosion on the inner insulation on the inside of that wiring sheath. Maybe we can skin that back and show you so you completely understand and can see what happens to wire that isn't tin coated when you use it in your boat, or copper wire that isn't correctly sealed from the atmosphere at the ends if you use it in your boat. So remember, here at Thumbs Up Charter Services, we are wild for walleye. You can find us on Google in Seawing or Harbor Beach, Michigan, or you can visit us on the web at thumbsupcharter.com. Thanks again for joining us, and we'll see you soon.